Well, hello there. Welcome to Midnight Coding with Dr. Wisby. Sometimes the only time you have to code is after midnight. After all the sports are done and the activities are finished. This is the time that I have, and so I'll spend it with you. Thanks for joining me. Let's get right to it. Okay, through calculus, it is possible to show that the limit of e to the x minus 1 divided by x equals 1 right here. We need to do this in MATLAB, and there's some clues here. Okay, I think we can write a script. I think we can do it. The format of your numbers should be long. This is going to be important because we want to see how close we get to the value. What? And so we're going to need to put that in there. And then there's another function right here, display limit. And that big clue there, there's an apostrophe. What did we learn about apostrophes? They give you the transpose of an array. Big clue. Okay, I think that there's gonna need to be a limit called array. No, an array called limit. Yeah, that sounds good. Well, let's get right to it. All right, I've already started one here. And I'm gonna say, we're gonna write here, Dr. Wisby, midnight coding. Find the limits for part B. Let's see what we can get. First of all, I don't want to have to change my script every time. Oh no, that's not it. I don't want that. And so I'm gonna save this one. We're gonna call it the limits. This program. Limit, why not? There we go. But we just fine. We're gonna call our array something else. I don't like calling arrays the same name as functions because I feel like it's gonna cause issues. Okay, that's fine. All right, I remember some old code that I have. I wanna actually ask the user what the limit should be. So I'm gonna go back to my old code here. I've already got it highlighted. I'm gonna copy this because I'm gonna prompt the user. Yeah, to enter the limit. I'm gonna say prompt. Okay, right here. We're gonna display the limit. Okay, so I've got some stuff here. This program plots sine of x. No, okay. This program finds the limit of the function e to the x minus 1. And that's all divided by, I think it was x. I think so. Well, let's go back and check. There it is, and that equals 1. That's the program. That's the function that we're going to evaluate. But first, we're going to make an array, and I'm going to say prompt. I'm going to say in is, that's the number of steps. So we're going to ask the user, enter the number of steps. Okay. There we go. Now we're going to create an array. Okay, we're going to say this is going to be 1 to n. That's array. We're just making an array of things to fit into our function. And then we're going to put the results of that equation into an array. But let's see, let's check on the value in here. And look what I did here. I called this in and I said the limit is in. I don't like that. That's going to be, we'll call this number of steps in steps. You just need to call the variables something else because sometimes MATLAB gets confused, okay? So I'm going to save this, and then I'm going to go down here to the command window. And I'm going to type that in. I'm going to say limit. Show me what you got. This program, enter the number of steps. Let's do 10. Oh, look at that. Now we have a function in with 10 steps. And if I say, give me the transpose of that limit, boom, we did it. Okay, so now the program is going to prompt the user to ask how many steps that you want in this program. Okay, and let's go back to the original problem here. It says, as x goes to 0, this should go to 1. So are we doing this right? I think no, because we want x to get closer and closer to 0. So as x goes to 0. Interesting problem. We're gonna have to adjust this because it's not what I initially thought. Because we don't want in the number of steps, although we could. No, let's change that. As I don't know if we need to. You know what? I'm gonna save this one for later because I really like this program, but it's not the right thing. Okay, we're gonna start over. I don't like that one. All right, so we're gonna copy this. We'll go to our new one. Okay. Now it says that as x goes to 0, so we want x to get smaller and smaller and smaller. Okay. That's fine. So what can we do? Let's just make an array here. You know what? Actually, I'm thinking now this wasn't really so bad after all. No, it was. Let's make a new one. I don't like that one. Okay. We're gonna make a new array. We're gonna call this in, and we're gonna say we're gonna go from 1, and we're gonna do 0.01. Okay, this is gonna be our step size. Yeah, and then we're gonna go to 0, and this is just gonna make an array. We're gonna call this function limit to. You know what the great thing is about MATLAB is you don't always have to know what you're doing before you start. You can just start coding and then realize, hey, that was a terrible idea, and then go a completely different way. Because you know what? You don't always have to know the answer right away. That's fine. Now we're just going to test this in. And, oh, no, it didn't like that one. What did we do? Oh, because we should have said minus. Yeah, because it has to go from 1 to 0. Otherwise, it doesn't know what to do. That's fine. I'll type this in. Oh, that looks great. Okay. So we've got 100. We got 100 places. Okay. Now we need to make another array. And I don't want to see the outputs anymore. I'm done. I'm done with the output. You know, we could also make this smaller here. Okay. And so, that's fine. If it was earlier, I could figure out a much clever way to do this, but it's getting late and we're just going to do it the dirty way. All right. So we're going to create a variable called limit e. So it's going to be the limit of e. Okay, no. Stop. Oh, okay. The limit of e, okay, and this is going to equal. Now we're going to go back to our function here. And this is nice because you know what? Oh, I don't know how to get the value of e. If we just type in e here, nope, it doesn't do it. What about e? No, I didn't mean that. What's the capital E? It doesn't have the value e. Wow. Okay. Create a new tab. How to get e in MATLAB. Oh, there it is. Use exponent 1, and we knew that. We definitely knew that. Okay. So the exponent. What? Function in -1. And it's going to be divided by x. Okay. It should work. And we need another parentheses here. All right. So this should create a variable, okay, an array with the limit of e. And each element of the array is going to be smaller and smaller. So I'm going to say limit of e, and we'll put an apostrophe there because we want the transpose matrix. We'll save it. Okay. Then we'll type in our function here, limit 2. Answer. This program finds. No, it didn't work. Why does it only have one value? I know why, because we didn't do dot divide. You always wondered, when do we need to do that? Oh, there's the answer. This is the time when you need to do it. Okay, this is the time. All right, that's fine. We need to think of a clever way here. Okay, so I'm just gonna add some more zeros here, and then we'll be able to see what this comes out as. I'm gonna save this. We'll save. Okay. Then we'll say limit. Oh, look at how close. Look at how close we're getting to 1. You know what? We should just plot this while we're at it. I mean, what the heck? We can do that now. Let's say plot of n, big N, and limit of e. There it is. Plot of e. Oh, I did mean that. Thank you. We should have a plot now. What did we even plot? Oh, it's hard to say. Hold off. I don't want to see that anymore. You know what? I'm going to close this figure because I don't get it. And we're going to put this in our script because we want to see it. There we go. Plot. Save it. And there it is. And it's really, it's not really convincing. Oh, you know what? It's because I made my array backwards. You know what? That's fine. I can fix that. What I'm going to do is I'm going to say this is 0 here and this is 1. Okay. But you know what? I am going to do something clever here. And I'm going to actually, I am going to do a prompt. I'm going to put these in here. Okay. But it's going to be not what you think it is. Okay. So what I'm going to do here is I'm going to say 0.1. I'm say dot exponent. I'm going to say, we'll come back to that. Put this command here. Prompt. Okay, so I'm going to say prompt. This program finds the limit of a function. Okay, that's good. Okay, then in step size is, and here I'm going to put in step. Yes. And so what I can do is I can say, okay, 0.1 to the power of 100. Okay. Oh, that's a really small number. And so I can make an arbitrary number of step sizes by running this function. Okay, so I'm going to put this in here. Now, I'm going to say, nope, I don't want that. Limit 2. Okay, this program finds the limit of the function e to the x minus 1. Enter the number of steps. I'm going to do 10. That's a lot. Okay. Oh, and oh. Requested. The array exceeds. Why is it when we get to 10? Oh, there we go. Wow. Okay. So, let's see. 0.1 to the power of 10 is, okay. That's really nice. Okay. So we want to say, seems innocuous, but okay. Well, So that's probably all we can do. We're at the limit here. Let's see when. Oh, oh goodness. Okay, 100,000. That's pretty close to zero. Hmm. Okay, well, we'll just run our code and we'll just keep that 5. There we go. Okay. Limit of 2. Okay, we'll keep this at 4 here. Okay. Looks good. We'll go to our plot here, and we don't want that. Plot in limits. Yeah, you know what? Let's just do pi divided by n step. There we go. Okay. This is better. I think this is gonna fix our problem because I don't know what's going on here. Okay. Not number. And it's not plotting. Why isn't it plot? Oh, it did plot. Oh, just can see it. Hmm. So as 1 goes to 0, this does look like it approaches 0. Okay. Okay, we're gonna go past 0. We'll go to -1 there, just so we can get a feel here. We'll go to 10,000. Okay, so right here at 0, it does approach 0. Okay, well, hmm. Okay, so let's go back to 0 here. Let's see, 100. Oh, look at our plot. As this is going from 1 to 0, it looks like it gets pretty darn close. So we can say that this is definitely approaching 0, but now we need to use the function limit because this will tell us what this thing is going to approach. Okay, the actual limit. And let's say display limit. Well, it looks good to me. I'm convinced it's the limit. I think it's good. All right, let's go on to the next one. All right, problem Z. For this problem, we consider the motion of a ball under the force of gravity. Classic physics. Gravity. We will ignore the factors such as air resistance and assume g is equal to 9.8 to be the acceleration due to gravity measured in meters per second squared. If a ball is thrown vertically with an initial velocity of v0 measured in meters per second, it will remain in the air for 2v0 g seconds. Its height at time t is measured in meters will be following. Okay. Write a script baseball that creates a vector named time with 25 evenly spaced values from 0 to 2vz g. Then compute another vector named height that tracks the corresponding height for each time using the above formula. Okay. Test your problems using an initial velocity of 43.81 meters per second, the equivalent of 98.98 miles per hour fastball, to produce a 2-column display of your results. Use the command display time and heights. Lastly, use the max function to find the maximum value for your height vector and store this variable called max height. Wow. That is a lot to unpack. And I think to be able to do this problem, you have to understand the physics of what's going on. Because if you're just trying to do a problem and you don't actually know like what's happening in the problem, I don't believe that you can solve the problem. Okay. So I think first, in order to attack this problem, we need to go back and talk about what's happening with the physics, because this is a physics problem. And really what you're doing is you're going to have a projectile and it's going to go up in the air and it's going to come back down. Okay. If I throw the ball up in the air, okay, and maybe, maybe that's why a physicist should teach this course. Let's talk a little bit about physics, guys. I am a physicist. I have a PhD in physics, so I can teach you about this. All right, so if I throw this up in the air, well, actually, let's turn off my background. Well, let's do a small one. If I throw it up in the air, it comes back down. Now it takes some time to do that. Okay, again, it's going to go up like this. Okay, it's going to go up in the air, and the background is. Let's turn off the background. Okay, here it is. I guess you can't blur my background. All right, there's my office. I have this picture over here. See, it says "Make art, not war. Don't kill people. Make paintings." Okay, so if I throw this up in the air, it comes back down, and it takes a certain amount of time in order to do that. Okay, and so now that we understand how the physics is working, okay, things go up and they fall back down unless you're out here in space, and then I mean, which way is even up? You fall this way towards the center of this galaxy, and there's probably a supermassive black hole that holds everything together. But let's get back to our problem here. And you're probably kind of freaking out because you're like, oh man, Dr. Wisby, there's a lot of words in this problem. What does all this stuff mean? What am I doing here? Okay, the thing to remember is that this is just a formula. And this formula here is telling you what the height of your projectile is going to be as a function of time. You can map the whole thing out with time. Okay, so we know how high it is, and it falls back down. And it's going to fall back down, and we can make a plot of it. So we can make a plot of this thing going up and down. So our x-axis is going to be time, and the y-axis is going to be height. And you should really make a plot of this, because if you don't make a plot, I don't think you really understand it. There are these mathematicians that are like, this really, I think it was Descartes. He was a famous mathematician. He wrote this amazing book on math, and he was so proud of himself because he's like, I didn't even need to use a single figure. And I thought to myself, what a horrible textbook. A math book without figures? Oh my gosh, that's absolutely the worst. I'm a very visual person. That just sounds horrible to me. Even if it was written by Descartes, it's fine. Okay. Let's talk about our variables here. Okay. H is how high the projectile is off the ground. Okay. And it's going to be launched with some initial velocity. If it doesn't have an initial velocity going up, it's not going to leave the ground. Right. I have this coffee cup here. It has zero initial velocity, and you can see how it's moving. It's not moving. It doesn't move anywhere. So we need to have an initial velocity going up. And we're gonna create a time variable with an array of time values. Okay. And it even tells us how many do you want. Okay. It says a time with 25 evenly spaced values from 0 to 2 VZ of G. Then compute another vector named height that tracks the corresponding height for each time using the above formula. Okay, so two arrays, one of time with 25 spaces, okay? And then the other one is your height. So you got time and height, two columns. That's what we've been talking about. Your data is two columns. One is height and the other is time. So position and time, right? And then G, we know what G is. It tells us in the problem that's 9.8. Okay, so It's a physics one problem. It's not that scary, but we need to figure out how to do 25 values of time. And the end here, 2v0 of g, that's just your initial velocity times 2 divided by 9.8. That's your final time. Okay, so really important when you're writing these programs, you need to understand the problem that you're trying to solve. Because if you don't understand the problem, why are you writing the code? I don't know. It's probably wrong. Okay, so we're going to save this. We're going to call it baseball. Yeah, that looks like a good one. And I've created so many amazing programs already. Wow. All right, so I'm going to document my code. We're going to call it baseball problem. Put my name there. Oh, look at that. Even added another percentage time. Wow. Dr. Wisby. I'm going to put the date 9/12/2023. Okay. This program solves projectile. That's all it does. Okay. So the first one is let's recall a function named line space. We just did this one. Okay, this is going to fill up an array with evenly spaced values. Okay, and let's try and remember it. Let's call this t, and we're going to say t equals line space. Here's our function. Okay, I think it's a function, and we're going to say from 0 up to 2 in our initial velocity v0. In the problem, it says right here 43.81 meters per second. Okay, times 43.81. We're gonna leave the units out because I don't know how MATLAB is gonna deal with the units, but we can add those back in later if we want to. Okay. Mathematica, you can put in units, you can make up whatever units you want, and it's fine. I don't think MATLAB is that way. So we're gonna leave the units out. Okay. So first things first, we're just gonna create this time array. Okay, this part's not scary. We're just saying, oh, and we didn't say how many intervals we wanted. We want 25. Okay, so from 0 to our final value. And you know what? Maybe we should put this up here to make it less confusing. So we're going to call this V0. And we'll say V0 is going to be 43.81. Okay. Put it semicolon there so it doesn't display that. And then I'm going to say G is equal to 9.8. Okay, so I've got my two variables here. Right. And now I can go back here, and now this will make it a lot less confusing. I'll say V0. I just did VO. It's not actually 0 divided by G. And let's just run this and see what we get. Okay. This is just our time array. And that's all. Oh, no. All baseball. Okay. Line space. Nope. Didn't do it like, okay. Line space. I know there was a command. What was it? What was it? Maybe the help. Nope, I don't remember. We're gonna have to go back and look. I thought I knew the command, but I didn't. But I know that there is a command. Okay, and I think it was here under vectorize operations, or it was probably the first day. I can see the page in my mind. And we're gonna go back to two-dimensional arrays in MATLAB. See, knowing the code is extremely useful. I forgot. Look at that. Vectorize two-dimensional arrays. That sounds right. Yeah, it's right there. It says, oh, it's lin space. Oh, the cursed vowel. I knew it. It was lin space. Okay, not line space. You know what? It's fine because Put an E there. Take out the E. That happens sometimes. I knew what the command was. Nope. No dice. Air in baseball. I didn't like it. Oh, let's put a dot there and see if that works. Save it. Nope. No dice. Line 6. Yeah, I know where it is. All right. It said linspace. It should work. We're doing everything correctly. Oh, dang it. Should add commas. It's the commas. So now we've got the syntax of MATLAB. Sometimes you have to use commas and sometimes you use colons. There we go. Okay. So we've got 25. Wait, is that 25? Nope, it is not. Oh, mix these up. Okay, so this is our upper limit. Okay, and we're gonna do comma. And you know what? I don't care if I'm making mistakes because it's fine. Everybody makes mistakes. Nobody can write this code the first time perfectly, but that's okay. It doesn't have to be perfect. All right, now we got baseball. Okay. So now we did it. We've got from 0, okay, to this final value here, 2 times VZ over G with 25 evenly spaced numbers, right? We used linspace. I thought it was line space. I don't know. That's fine. That E really messed me up. And each value is separated by commas. Why do they use this commas instead of colons in this one? I don't know. You just use commas here. This is the syntax of MATLAB. Maybe. I'm sure that there's a reason. Okay. I'm sure that when they were designing it, there was some reason they did that. It doesn't matter. Okay, so let's go back to the homework here and let's look at homework number 2. All right. So now we just need to put this equation in and make HT an array, and we've basically done it. We've solved the problem here. Okay. And they talk about vectors and arrays, but in physics, a vector means something very specifically. In MATLAB, a vector is just an array with three columns or one row and a bunch of columns. I like to think of everything as an array, okay? Because arrays is a very general term. Technically, it is a vector, okay? And it's fine, okay? And so, in this problem is a little bit confusing because it has vectors from the sense of physics, but then it also has vectors from MATLAB, which we know are just a row of values, okay? But basically, you need to remember what we're doing here. We're computing the height of this baseball as a function of time, and that's what we're going to plot, height versus time. Think about baseball going up and then coming down. That's all we're doing here. We're going to plot this, okay? On your calculator, you wouldn't need to make these arrays, but this is how MATLAB plots things. Each in a computer language, it's like sometimes certain things are easier, but then you pay for that ease by it has to be difficult somewhere else, okay? Since MATLAB, I feel like, it's so just wild and loose with the way that you index things that, then other areas are more complicated. So you always have to deal with these matrices or arrays or vectors, okay? Which it's not totally intuitive, but I think once you get used to it, it's fine. Okay, so here's our formula. And we can just we'll just put this right in here, okay? We're gonna make another array, we'll call this HT, we'll say equals, and then we already have our value there, V0, okay? And we're gonna say dot asterisk times T minus 9.8. Oh. Mr. Zeus came to help me. Oh, hello there, Mr. Zeus. All right. Do you want to push some buttons? Nah, Mr. Zeus loves me. He's really old, but you can sit over here, Mr. Zeus, until I'm done. Okay. Well, now we're going to say dot asterisk times t to the power of 2. Yes. And then we're going to say divided by 2. I think it's good. I think it's good. Okay. So we should have 2 rays now, and then we're going to plot these things. We're going to plot, okay, T versus HT. There we go. Oh, he even did it for us. Wow. Okay. We're going to display those things, but you really need a plot. Okay. If you're doing this problem, you need to plot it. Okay. And you could do it by hand, but why not use MATLAB? All right. So we're going to save this thing. I hit Command S on my keyboard. I don't actually go to the menu. I don't go up here. And then, oh, I don't even know where save is. What's this one do? Browse for folder. No. No. I'm not going to open the menu. Oh, there's the picture of the floppy disk. It's right there. Save. Saved it. I don't do that. I hit Command S. Okay. So now we're going to type in baseball. Nope, that wasn't it. Baseball. Okay, and we should have a plot here. Oh, there it is. There is the plot of our baseball. Oh, and we apparently, no, it's zooming out. No, stop it. Stop it. Oh. There's our baseball. So the bottom axis is time, and we're just going to put that in here, okay? We're going to say Y label. We're going to say time. We'll put the units, okay? That's how you put the units in there. Okay, X label. Because we know how to do this now. What did I just say? No. The Y label, that's heights. This is time. The x-axis is time, and the y label is heights. And we'll call this meters, okay? And then we'll say legend. Baseball. Okay, and what do we want the plot? We should make the plot look like a baseball, right? I mean, we can do that, okay? So let's make it actually look like a baseball, man. Okay, so we're gonna say, I think it's apostrophe. We're gonna say, oh, oh, there we go. That should do it. And we want it to be, red. Yeah. Okay, so we got our label here. We've got a legend. We'll say plot label. Oh, I don't remember. Now we're gonna have to go back and check. I thought it was called plot label, but apparently it's not. It's not plot label because that didn't pop up. So we're gonna go back to the plotting page, plotting data. There it is, and we want to label the plots. Title, of course. Title, and we're gonna say flight of the baseball. We did it. Wow. Who knew we could make such a wonderful, amazing, oh, and it even looks like a baseball. Huh. Wow, I'm blown away by my own plot. Look at this. We've got a label there. It's a baseball, okay, not a football. Okay. We've got flight of the baseball and height. in meters, and we've got time there. Wow. And you know what? I'm gonna turn on our grid line. So grid. Okay, again, I forgot what we're doing here. I thought it was grid line on, but it's not popping up. Oh, here we go. Oh, it's just grid on. Okay. Grid on. There we go. Boom. Boom. Let's run this bad boy. But you know what? I don't want to look at all those vectors. It hurts me. It hurts my face to look at those vectors. I don't want to see those. I don't want to see the numbers. I just want the plot to change. Oh, you know what? This has changed the way that I'm going to teach physics, because next time I teach physics, everyone's using MATLAB. Yeah, I don't usually make them do that, but I feel like this is a power that has gone unchecked for many years. Well, we did probably more than we should have. We did B and C. I'm going to leave D up to you because it's already 12:30 and I got to get up in the morning. But with these two problems, you should be able to get started and at least get a good start in these things, okay? So if you have trouble with D, I might post another video tomorrow and we can take a look at D, but that's about all we're going to do for now. So thanks for watching and have a great night.
Thank you, like and subscribe down below.